accelerate and brake too often. Unstable traffic flow wastes energy. The table below gives one example of traffic speeds in kilometers per hour in an unstable flow situation. All right, so that you don't really need that information. You go straight to the question. If you look at the question, it says, what is the mean speed in kilometers per hour in this situation? Well, remember, it's telling you, it's giving you a clue right here. Kilometers per hour, okay? So you're going to get the kilometers, and you're going to divide it by the hours, okay? So let's take a look. Okay, oh, it's already been done. Look, it says kilometers per hour right here. See? So it says the mean. So remember, how do you get the mean? So in order to get the mean, you're going to add all the values that you have for the speed, 30, 20, 50, 70, 20, 70, and 20. You're going to add all those numbers and divide by 7 because you have 7 numbers. So we're going to divide by 7. So let's go ahead and do that, okay? So I have already I've discovered this calculator which is on the website, which is the closest thing that I can get to a TI-30XS multi-view for free. So it doesn't look exactly the same, but it works exactly the same, and it's free. So let me go ahead and do that. Okay, I'm gonna start adding these numbers: 30, 20, 50, 70, 20, 70, and 20. So let me do that. Okay, 30 plus 20 plus 50 plus 70 plus 20 plus 70 plus 20. All right, and I get 280, and then of course I have how many numbers? 1, 2, 3, 4, 5, 6, 7. So I'm going to divide by 7, and I get 40. I don't really care about the time because it's not even asking us about the time. It's just asking us what's the mean speed. So get them all, add them up, divide by how many you have, and there's your mean, okay? So I'm going to go with 40. I'm going to click on 40 right here. Okay. And go to the next one. Okay, let's see what this is. Okay, the cell cycle can be divided into 2 phases, interphase and mitosis, which is cell division. Mitosis is further subdivided into prophase, metaphase, anaphase, and telophase. A lab technician observed 200 cells from a cell line and recorded the number of cells in each phase of the cell line. The results are shown in this table. So, all right, let's take a look at this. In each one of these phases, so this is all the phases of mitosis, the lab technician observed this number of cells in each phase, okay? Now, based on the data, what is the probability a random chosen cell will be observed undergoing cell division? All right, so this is really a mathematical question. It's about probability, okay? Now remember, probability is what you're looking for, okay? The desired outcome or whatever, divided by the total outcomes. So let's go ahead and, okay, let me see. Let's visualize this thing. Okay, I'm try to make this smaller. It's not going to be in the way. All right, so we're going to have all desired outcomes. Okay, try to, okay, let's size that too small. Not what I want. I'm getting kind of rusty here. There it is. So it's everything, all outcomes, or all possibilities. Wait a minute, forget about that. Scratch that, guys. Just ignore that. It's going to be all possibilities. Okay, that's going to be the bottom number. Okay. And then the top number is going to be desired outcomes, the desired, yeah, whatever you're looking for, basically. It's not handwriting. On this test, you don't have to rush. Now that, if you know what you're doing, okay. So let's see. All right, so the desired outcome is Let's see. Randomly chosen was undergoing cell division. Okay. Let's see. Okay, so mitosis is cell division, and cell division is, let me see, is prophase, metaphase, anaphase, and telophase. So these four are cell division. Okay, those four are cell division. Okay, so those four are cell division. Interphase is not cell division. Okay, so what we're going to do is we're going to go ahead and add everything. That's going to be the bottom number. We add everything. Okay, so let me get the calculator and do that. All right, so it's going to be, let's figure this out, 170 plus 20 plus 4 plus 2 plus 4. 200. That's the bottom number. Okay. And then it says, let's see what we have. What's the probability that a random chosen cell will be undergoing cell division? So we know that cell division is the last four phases. It says it here. Mitosis, which is cell division, is further divided into prophase, metaphase, anaphase, and telophase. So those four are cell division. Okay, according to this thing. Let's see. So let's add up the top number, these numbers, 20 plus 4 plus 2 plus 4, and that's going to be the top number. So let me do that. Okay, so it's going to be 20 plus 4 plus 2 plus 4. That's 30. All right, so it's 30 divided by 200. Okay, so let's do that. So 30 divided by 200 is 0.15, and then if we multiply that times 100 to get the percent, we can transform it. That's 15%, okay, which is right here. So I'm going to go with 15%, okay, do that. So far it's basically math problems is what we've seen, okay. Let's see what's next. Okay. All right, so let's see. It says scientists today are studying tidal power as an alternative energy source for generating electricity. Some scientists conclude that tidal power is a good alternative source of energy because it uses a natural process and does not rely on fossil fuels and does not release greenhouse gases. These scientists recommend building tidal power plants around the U.S. in locations with high tidal power potential. Other scientists conclude that tidal power is not a good alternative energy source because tidal power plants can negatively impact the surrounding ecosystem by killing marine animals, restricting fish migration, reducing the natural flow of water, and causing silt buildup in waterways. These scientists recommend not building tidal power plants in the U.S. waterways. Okay, so it says both conclusions are based on valid data and scientific reasoning. How can they both be valid? Well, it turns out that one of these scientists is looking at the positive side of it, right? It says, well, these are good things. It's a natural process. We don't have to burn fossil fuels, and there's no pollution, and so on, right? And then the other scientist says, no, this is actually bad. It's going to kill marine animals. It's going to restrict fish migration, and it's going to restrict the natural flow of water, and so on. So these two guys or ladies, they're looking at this from opposite viewpoints, right? So let's take a look at the answers we have here. It says, A, the two groups of scientists believe different theories about the process. No, they both understand that does generate electricity. So that's not in question. So it can't be A. B, the two groups of scientists are looking at different specific aspects of the same scientific problem. It could be B, okay? C, the two groups of scientists collect and analyze data about all types of possible, no, it doesn't say that here. They're not looking at all possible alternative energy sources. They're just talking about tidal power. And then D, the two groups of scientists are on opposite sides of the debate on whether the U.S. needs to find, okay, it doesn't say that either, because this is just one person is looking at the positive aspects of tidal power. The other one is looking at the negative aspects of tidal power. So this is kind of a language arts question is what we have here, okay? So I'm going to go with B, okay? And let's proceed. Okay, let's see. Okay, read this paragraph about the benefits of a green roof. A green roof is created by adding soil and plants to a specifically designed roof. So it's a special roof that you can plant stuff on the roof. Scientific research has shown that a green roof has many benefits compared with traditional roofs. Plants naturally absorb energy from the sun and convert it into chemical energy that is stored in the bonds of sugars during photosynthesis. The soil materials also help insulate the building. In addition, green roof helps control runoff as plant roots absorb rainwater. Okay. If local plants are used in a green roof, it may provide habitat for native species. So this is all the good stuff about having a green roof. So look at this. Which sentence from the paragraph supports the main idea, or the idea, not the main idea, the idea that green roofs can reduce cooling costs? Okay, guys, it's talking about cooling costs. So all the stuff that we read here in that passage, which of these actually refers to cooling, something that helps cool the home or cool the structure? Okay, so let's go over it again. Let's see. A green roof, blah, blah, blah. It says plants naturally absorb energy from the sun and convert it into chemical energy. Oh, that's great, but that doesn't help you cool a place. The soil materials help. Oh, look at this. They help insulate the building. Well, insulation is one key component of keeping a building warm or cool as needed. So I'm going to go with this one. Let me see if it's here. Green roof has, no, that's just a general thing. Plants naturally absorb energy from the sun and convert. See, this doesn't have anything to do with cooling the structure. The soil materials,